Hey everyone, this is the Sig-Auth meeting for July 19th, 2023. I think we have a light agenda today. For folks that weren't aware, yesterday was code freeze for 128. If you forgot, then it might be a little late. Otherwise, if you have some exceptions or anything in, hope those get approved and get your stuff done. Otherwise, anyone have any announcements or anything they want to discuss before we move on to the main discussion topic, which is a SIG storage cap? Open. Radio. So I scanned this cap, but I didn't necessarily fully read it or understand it yet. Let's see. So Carl and others, are y'all on the call?
Yeah, we're here.
I have a slide deck for the cap,
Okay.
which is in the chat.
Would you like me to make you host so you can present it?
That would be great, yes.
All right, one moment. Sorry.
So while Carl is getting set up, I just want to do a quick background / context intro there. I know the cap itself is huge. So we are hoping to break it down and pick apart things that are only relevant to the focus of this meeting. So yeah, in a nutshell, this is a SIG storage data protection working group cap. And I know some of you may have seen this cap floating around since late last year. The idea is to introduce this new CSI API into the CSI spec that allows user to pull and request change block tracking data. And what that really means is if you can imagine a user has a stateful workload attached to a CSI PVC that could be anywhere from 1 to 10 terabytes of data, say on a somewhat typical the relational databases out there. And when we want to do backups of the CSI volume, right, instead of every time have the backup software or the CSI driver try to walk or back up the entire 10 terabytes of data, change block tracking is the kind of service that allows the backup software to say, okay, between Tn and Tn minus 1, what are the deltas and changes that have happened at the block level in this volume, and give me back those delta, and I'll only back up those deltas. So, and the reason why we are here is because we last year, as some of you who have seen this cap floating around might remember, we have tried multiple approach to try to implement and present this CSI API. Challenge there is the amount of data, if you can imagine, that comes back from the provider, the storage provider, can be huge, right? Say, in the worst case scenario, every block on the disk have changed. Then you have 10 terabytes of, or at least hundreds of gigabytes of metadata coming back, going through the SCD, going through Kubernetes API server, finally back to the consumer. So we have to kind of in a way think out of the box, and so that the conventional CRD / controller approach is not going to work. We tried the aggregated API server approach that got shut down because of this unbounded amount of data that can flow through the Kubernetes control plane. So we tried to put together and devise a gRPC streaming endpoint. And then part of the requirements is that this has to be secured from a workload as well as cluster security perspective. So hence we want to take the time to walk everyone through the focus of the cap and zoom in especially on the security aspect of it, and get some advice from you folks to see is this the right way to do it, what are the gotchas, and how to proceed from here. So Carl, want to take us through it?
Thanks, David. Yeah, so okay, so this is various iterations. So this particular slide deck matches what's in the published cap. And, hopefully, if you all look at this, it'll help understand what we've written out there. So as Ivan mentioned, the goals of this design iteration, and there were two previous iterations, right, was to provide a secure and idiomatic CSI API to, is all buzzwords, okay, efficiently identify, okay, blah, blah, blah. But, the point is, we're going to get change blocks from a volume snapshot, between two volume snapshots, and all the allocated blocks of a snapshot in order to do efficient backup at the block node level. Now, so the technical details of how to do that are pretty straightforward and well defined by industry. The issue really is integrating this into Kubernetes. And the requirements for us, are like, we cannot be any less secure than the Kubernetes API itself. And we cannot, we have to use the existing container orchestrator, storage provider interaction pattern used by the CSI API implementations today, right? We can't impose additional constraints on the service, on the storage provider, right? To do anything extra fancy in terms of how we implement this. By the CO-SP, these are like terminology from the CSI spec. So I'm just reusing it, these abbreviations. Then we have to relay a large amount of snapshot metadata without overloading the Kubernetes API server. And as Ivan mentioned, right, through previous couple of iterations, we figured out that the only way to get this is to just bypass the Kubernetes API server, because no matter what solution we do, it's going to go through the Kubernetes API server. So we have to make sure that whatever we're doing, adheres to these, these are the goals for this iteration. I'm very briefly going to flash this at you and move on because it's not relevant to the presentation we want to make. We want you guys to examine the security aspects of what we're proposing. This is the use of an API. That's what we want to check, that our use of this API is secure, not the details of the API. But just for background information, it's a gRPC service, right, which has a couple of RPC calls. One's called get allocated, that returns all the metadata on the blocks of a single snapshot. And the other is called get delta, which will return the metadata on the changes between two snapshots. And the rest of these couple of slides just gives us the detail and the format of how we represent stuff, right? So it's all there in the written cap, but it's just interest of time. I'm not going to go through this data right now. So I want to talk about what we are proposing. So the CSI spec is supposedly independent of any container orchestration. But reality is, we're doing this from the point of view of Kubernetes. So this is our Kubernetes implementation to use that spec. So our solution requires that a Kubernetes backup application will directly connect to this gRPC I just showed you and fetch the change block metadata through this API, bypassing the Kubernetes API service. So the way our solution rolls, the backup application has to create a snapshot session request CR to set up a snapshot session, and which authorizes the use of this direct connection. And as you can imagine, right, we're talking to you mainly about all these authorization related issues. We'll provide a snapshot session manager to be the controller of this CR. And this manager will support all the participating CSI drivers in any cluster, right? Though an individual session cannot span multiple drivers. It's per driver. And there'll also be a community provided sidecar. We call it the external snapshot session sidecar. And that's provided so that the storage provider can be isolated and insulated from the Kubernetes side of managing the session. And so I'll go into the details as we go back, but just keep in mind what the overall solution is. So I'll start with this very intimidating picture, right, which has big picture of everything. And we'll zoom in. Some of you may not even be able to read it. It's got so much detail, but we'll zoom in through this and go into details as we go along. So let's start by dissecting what we're looking at. So given that we have a CSI sidecar, right, which the CSI driver is going to deploy. And this sidecar is going to be the part that interacts with the Kubernetes clients, right? And whereas the actual vendor-specific logic used to get the change block or snapshot blocks is going to be handled by the SP snapshot session service. And existing paradigms today says that the sidecar pattern is used very commonly with CSI. And the existing paradigm today is that the sidecar talks to the CSI piece through a Unix domain socket. So there's no security ramifications, particularly over here for this thing. It's deployed by the SP vendor. But the most important takeaway from this is that the storage provider doesn't see Kubernetes clients. The client of the storage provider is Kubernetes, the container orchestration, the entire system, right? And it's securely set up to work with the system. The clients of the Kubernetes clients are not clients of the storage provider. That's a really important takeaway from this part. So over here we see that, so this is one security domain, the gray one, the gray area. It's the Unix domain socket stuff. It's already an established pattern. We're just using this pattern, and we provide the sidecar to handle the Kubernetes side of it. Now, our design requires that a Kubernetes backup application is going to directly use this gRPC service. So the sidecar we provide offers such a service, right? And Kubernetes backup applications run in the cluster. So we're really going to make TCP/IP-based gRPC calls to the sidecar. Now, the tricky thing is these are TLS calls, not this is like there's no mutual authentication involved. Why? Well, the sidecar itself, we require it to be deployed with to provide a CA certificate and things like that, so that we can advertise the server side credentials to the client, and the client can trust the certificate, make all these secure calls, no problem. But we don't have, or we don't know, right? Our security is not our background, but we don't know of any standard mechanism for an arbitrary Kubernetes client to authenticate or validate itself to a Kubernetes application, right? So we didn't know about that. Yeah, we looked at various forms, and maybe we could emulate. Ideally we'd love to just use the whatever ID Kubernetes uses when we do, say, kubectl, right? We log in and we do stuff. We'd love to just use that. We'd love to use a service account, for example. We don't know how to. So at least without sucking in and maintaining and basically emulating or actually modeling what the Kubernetes API server does today. We do not want to put that logic into our sidecar. So all the rest of the solution is all around how do we validate this backup application's connection to the sidecar. So because the sidecar's address and certificate is well known, anyone can connect to it, but we can't let unauthorized entities connect to it. So the rest of the solution is all about this. How do we authenticate this stuff? So what we're really talking to you about is to validate what we're proposing over here in terms of this green box and how this whole session setup is done. And so that's the background of why this is such a big complex solution, at least visually. By the way, interrupt and ask questions anytime you want. So let's go over the high-level flow. So just to kind of recap of what I just said. So there's an independent manager which provides the snapshot session request CR controller. I'll get into some of the details later. There is this sidecar, and the sidecar is advertised to the manager by the presence of a simple CR, which just gives its CA certificate address, and there's a label on it so the manager can find it efficiently, etc. That's all standard stuff. Then a backup client will create a snapshot session request in the snapshot namespace. The manager handles this request, right? It gets invoked, and it will look for that sidecar and look for the service configuration object which advertises the sidecar, it finds it, then it authorizes the caller and creates a session data object with a large unique name. And this object is created in the namespace of the CSI driver. And the manager then gives the name of this object. It puts that name and the CA certificate and URL of the sidecar into the result of this session request CR. The backup client by itself does not have access to view or list these objects in the CSI namespace. Then the backup client then uses this session token and makes the gRPC calls. It's talking to the sidecar. The sidecar looks at that token, then goes and searches for that snapshot session data CR. The existence says, okay, the token is valid. And then it looks inside and finds the rest of the data required, what is authorized to be used, and does the rest of the validation of the RPC at runtime. And it then proxies this call to the storage provider session service over the Unix domain socket and proxies the results back. That's the high level view of the solution.
As a quick aside, I know you were mentioning that you did not want to get in the business of copying authentication logic or mimicking API server logic. You have built an authenticator here, just not a very good one, not to be mean about it.
No, it's not a good one. And yes, we have actually what we're doing is we're kind of doing it we rely on RBAC. So it's more like a delegation type of model, right? It's like
regardless of the schema, right? Like, for example, you store a secret inside of a non-secret custom resource, and then you copy it to a different one, right? When at the bare minimum, you didn't need to store the secret. You could have stored a hash of the secret. Like there's all sorts of better actual security ways. Jordan, go for it.
Yes, I'm sure.
Yeah, I'll let you finish talking through it, but I have some suggestions when you're done doing the walkthrough.
Yeah, please. That's why we're here. Right.
Okay.
Yeah, great. Go ahead.
Yeah. Do you want to stop now or finish?
Okay, let me finish. There's only a few more slides. I mean, the deck is big, but I'm only showing a few images, so it's not that much left.
Okay.
All right. So just go to the details. So the session setup, the storage provider is not involved at all. It's only on the community side, right? What we're providing over here. So starting off from when the snapshot session request is created, right? The application then creates that request and polls for the result. And so that's what the application does. The manager has a validating webhook to check the contents of the payload and validate the payload of the object. And then a little bit later, right, to the listeners on the controller, right, the manager's controller gets access. At this point, it actually goes and finds the CSI driver name from the snapshot objects mentioned. And then it searches for the snapshot configuration CR by using a label search. Once it finds that, then it creates this session data CR and updates the result with the token. This part is, so, how does this actually work from the point of view of the application? So, starting from where we left off in the previous slide, right, we had the snapshot session data CR sitting in the CSI namespace, and we have the session request results. So the client starts by trusting that CA certificate and then makes TLS gRPC calls, and it provides the IDs of the Kubernetes objects it's dealing with. Sorry. Yeah. The sidecar then, looks up that CR and uses it to validate the invoker's right to use it. And it then checks the RPC parameters, make sure they are correct as per the session, and does other types of stuff which are related to the actual request. And then it proxies the calls with all the translations required for the storage provider and proxies the results back to the client. So there was again, given our limited security background, we identified a couple of issues involved, which we had to address. One was the unintentional exposure to volume snapshot objects by an entity who's authorized to create this request CR. So essentially, we put a validating webhook in place to make sure that when you create this snapshot session request CR, you also have permissions to access volume snapshot objects in that same namespace. It's a namespace object. So that says, from a backup application perspective, just because you have permissions to create this request CR doesn't mean you have permissions to peep into, to use it to grab snapshot data from any arbitrary application. You also need access to the volume snapshots in that namespace in order to do this. That's what it was addressing. And then, we are worried obviously about the spoofing of the session token, because the sidecar's existence is well known. So the mitigating steps we take for this, we use a very long string of randomly chosen Kubernetes name characters for the name. We could use the name, or we could put the name in something else and use a token search. We can address all that, right? And that's what we are really talking about. Some of the feedback we want from you guys. More importantly, the visibility of this object is restricted by Kubernetes RBAC to the CSI driver and to the manager. Essentially, we don't want the backup application to have access to this. Then we also impose a lifetime on this object. So there's an expiry field in the object, and the expiry timeout is enforced by the sidecar and is enforced by the manager. The manager will also delete all these objects as they expire. So in a nutshell, these are the permissions we were defining. We are requiring, every CSI driver, right? In every infrastructure, they have their own ways of setting up policies to, do this. But essentially, so we have three principles involved here. There's the backup application service account, right? That one's going to need access to create these snapshot session requests or objects. And it's also going to need access to get volume snapshots in that same namespace. Then there's the snapshot session manager, which pretty much needs permissions on everything. Though on the configuration object, it's only going to get and list. It's not going to delete those objects. And there's the CSI driver service account. The CSI driver service account is going to need permissions to get, list, delete these snapshot session data objects. It definitely already has permissions to read volume snapshots, because it's the entity that has been creating these volume snapshots to start with. We assume that in our prototype, right, we actually used the role binding to make this happen, right? Because we essentially, if there are multiple CSI drivers and they're installed in different namespaces, then they are effectively isolated from one another with respect to the snapshot session data, because they have no business peeping into each other's data too. So that's the gist of what we have over here. The rest is just a link. So yeah, at this point, go ahead and poke holes in it.
So it sounds like you have, this is a good screen, if we could just sit on this one for a minute. So you have the backup application, which has a service account. So this is a Kubernetes service account already. So it has an identity. Yes. Am I understanding that correctly?
Yes.
Okay. And it's making Kubernetes API calls. So it's getting service account credentials somehow, probably running in a pod, being fed service account credentials.
Right.
And then the driver, so the token that you're envisioning this thing getting, it then passes in a gRPC request. Yes. To which of these actors?
Okay, so the token is going to be placed in this request as a result. Mm-hmm. So this backup application then makes a call to the sidecar. I do have to go back one. It makes a call to the sidecar here, passing this token on the gRPC.
Okay, and when jumping back to the page that has the actors, which actor is?
This is the sidecar.
This is the sidecar. Okay, so then it's going to take the token and validate it somehow that this is a good token and that it represents authorization to do this request. So it seems like are those the bits you're wanting feedback for? Like how to
Yes.
get this backup application to token, and then how the driver can use that token or verify that token is authorized. Is that
Yes.
what we're looking for? Okay.
Yes.
So a couple bits of feedback on the ideas presented here. So having a secret be the name of an object in etcd is actually really problematic for a few reasons. One is that anyone who has the ability to list those objects can see all of those secrets.
Yes.
So that's not great. And then even worse, the name of objects is used in their etcd storage paths. And so even if you like encrypted your storage information, the content of the storage in etcd, if the secret is the name of the object, that means the secret is unencrypted in the in etcd. So having it also shows up in other places. It shows up in the URL of the object when you request it, which can easily get logged. Like having the name of the object be the secret is not great. So just right off the bat, that's not a great thing. Fortunately, we do have a way to create tokens that can be used to verify identity to arbitrary audiences. So what I would recommend is using audience scoped service account tokens for this. So if the backup application is going to be making backup requests to some CSI driver, it can ask for a token for its service account, scoped to the audience of that CSI driver or CSI service. So that can be either a well-known name for that CSI driver, or it could be the service name of the CSI driver. I'm not sure how the backup application identifies the gRPC service it's going to make a call to, but it would say, please give me a token for my service account that is limited to the audience of this CSI driver. So it can either do this by making an API call to the Kubernetes API, or it could mount in a token into the pod. Like when you're setting up the pod definition for the backup application, you could say, inject a service account token for this audience. What that does.
Yeah. Can you give us some more details on this? So essentially you're saying, basically then it comes down to, going backwards is slow. It's this, so this whole green box goes away. I mean, that's what we are trying to do to start with.
Well, I don't know
Kind of.
what other information you're.
Yeah, right. Yeah, there's other information we have to check. Yeah, but it simplifies this tremendously. What you just said.
For the authentication and authorization parts, you don't need that anymore. Maybe you need it for other books.
Well,
around
we do need one thing though. We do need one thing, and that is, so that again, I don't know the APIs. You just say you know who can use this API for the audience scope service account token. But assuming that it's only doable by the backup client, right? How, when we pass it through, I mean, yes, this manager can validate the snapshot contents and all that part has to be done because the service account doesn't actually, the SP doesn't actually do that. So when it comes here, the fact that we have a management. So what checks that the service account, the backup client service account can create this audience scoped token?
Yeah, so there's two ways to get a token. One is to make the API request directly.
Okay.
And so that's just a normal API call. I'll link to the API. So that's a normal API call that's authorized in the normal way. So if you could do this in kubectl, like as a admin, you could say kubectl create token for this service account. And if you are authorized to, you can create a token. So you could do it directly with an API call, or you can put it into the pod spec. And at that point, you are running, you're defining a pod that's going to run as the backup application. And so you implicitly have the ability to get credentials for the backup application service account. Like you're running an application as that service account. And so anyone who can create a pod.
Right. The pod spec would have that. So by virtue of having made the call to get the token, the service account just carries those tokens with it.
You can request those tokens. So it automatically gets a token that identifies it to the API server. But what you're wanting to do is identify that service account to some other service, like the CSI service. So that doesn't happen automatically, but you can add things to the backup pod to say, I want to mount in a token to identify myself to the CSI backup service.
So Jordan, one of the we did look into like the token review and token request APIs, and one of the constraints, and I don't know if it is still like a hard constraint on our end right now, is when it comes to CSI spec, we try to be like platform agnostic as much as possible. It was brought up to us that like, great if we can couple ourselves to the Kubernetes token review and collection of APIs. But as much as possible, CSI tried to stay like platform agnostic.
Yeah,
Hence,
so
like, we got ourselves into this rabbit hole.
The CSI portion of it is agnostic. It's just an opaque token. So we're trying to figure out how to make use on either end, like the backup application running in Kubernetes context and a CSI snapshot service running in the Kubernetes context. Both of those are Kubernetes specific. So you're using the CSI plumbing. So the plumbing through the CSI gRPC request is just agnostic. It's just, here's a token, session token, sure. But the backup application is running in Kubernetes. And so it's going to get its token from Kubernetes. And the backup service is running in Kubernetes. And so it's going to verify the token against Kubernetes mechanisms. Right. So the proposal you have is verifying the token by making a Kubernetes request to see if there's an object named a certain way. So it's assuming Kubernetes.
Right.
It's just as reasonable for it to take a token and verify it using a token review to get the identity out and then do an authorization check on that identity.
Okay.
So the token verification part happens inside the CSI driver, right? It will still have to reach out to Kubernetes and say, hey, I got this token, check the scope and the subject.
I'm fuzzy about what happens in the sidecar and what happens in the driver. Like if the point of the sidecar is to do the Kubernetes specific things, and then hand it off to the CSI driver, and the CSI driver can assume that it was all authorized and verified already, that's a possibility. Like the sidecar can do that check. The sidecar can say, I'm running on behalf of CSI driver foo, so I'm going to take the session token, do a Kubernetes API call to do a token review to get out the identity, then turn around and do an authorization check on that identity. And once everything is happy, then I'll pass it through to the CSI driver. And the CSI driver just says, I assume this is okay now. I'm fuzzy on the line on what the role of the sidecar is in terms of enforcing Kubernetes specific stuff. Yeah.
So the sidecar really insulates the storage provider's service from Kubernetes clients. So it has to, it's basically, it's a proxy. So, it validates that the clients are correct, and then it just does the business logic stuff to the service provider using because the service provider, the storage provider has been set up to support the entire cluster, right? It's authorized to support the cluster, but it doesn't know about the individual clients within the cluster. That's the sidecar's job to do all that.
Yeah.
So I think in this case, though, to Jordan's point, though, that is your Kubernetes interface.
Yes.
Abstraction or hiding Kubernetes from your storage provider. So for that piece to be making internally a bunch of very Kubernetes specific calls over a generic CSI interface as like the data transfer mechanism seems totally valid, right? Because even in this design, that thing is going to make Kubernetes calls just to figure out like its auth decision based on these custom resources. So I think you're sort of well within that. The thing I want to highlight though in the proposal that Jordan just described, which was exactly what I was going to suggest, is you're not storing tokens anymore, right? They're generated ephemerally, ideally by the kubelet, and mounted into a memory-backed volumes on the kubelet, but you're not writing any secrets out to the Kubernetes API. Because the other
that's wonderful. That we really want to know how to do that. But I want to point out there are two pieces of information we require in the sidecar. And it's always we always face this dilemma of to get one, we give up the other. So right now, yes, assuming we can use an audience scoped token, right? A service account token. But we also have to convey to the sidecar the context under which we're operating, because we have done an authorization check, right? In the controller. Now, that authorization check could be done in the sidecar too, if that token can be used in the same way. See, right now, we are using a validating webhook to do that authorization check for the snapshots. And Kubernetes API is validating the actual construction of the CR, which is incidental because that's only about because we had to make a session. But that check to authorize access to snapshots is a SAR check, right? Prasad, chime in over here. Right? You know this. And can this service account token be used for the same check?
Exactly. Yeah, that's exactly what it can do. So there's two steps. One, you take the token and you do a token review to make sure that the token is valid for your audience. And what you get back is the user information, which you would then drop into a subject access review to do an authorization check. So it's two steps. One is verify the token and get the identity. And then the second step is to take that identity and check the authorization. And it's exactly the same as the subject access review checks you're doing in the webhook.
Okay, that's actually really cool.
Also, we already have code that does all of this. We even have roles and cluster roles and cluster role bindings already defined for this. We have written this code 1,000 times, so it's already in libraries.
Yeah. Cluster role bindings. We have to leave that to the CSI driver, but we can, because they already it deploys CSI things with all this stuff. So we just have to advise people how to set it, what, like I had in that last slide, this is what we need effectively, set it up in whatever policies you already have, right? So.
But yeah, I think if you can accurately model what you want in the way that sort of Kubernetes expects you to ask these questions, I think you could get the auth checks that you expect. I think can this identity or does this identity have list access on these resources within this namespace? Yeah, we can obviously help you answer that question very easily.
Yeah. Can you comment on the maintainability of whatever you're proposing? Because we are not in the business of security, and we just want to use APIs, not redo and repeat the same type of logic used elsewhere and has to be maintained over time.
Jordan, David, you can correct me, but I think this is pretty relatively well factored out in our code base. So I think they could just import it and reuse it, and then just bump the library whenever they want to.
Yeah, the token review and subject access review APIs are V1 and stable, and those are the foundation of everything Kubernetes does with delegated authentication and authorization. So they're not going anywhere. The API calls you make against those would continue to work even if we add things in the future. And there are helpers and pretty straightforward clients in Client Go that will do these things for you.
I was actually more thinking about the API server, like the aggregated API server code that does token review and subject access review using delegated authn and delegated auth. I feel like they could just reuse that in their gRPC handling?
I'm not sure they need all of that. Like they're getting a single token in a single field in a gRPC request, and they just need to.
Yeah, that's fair.
They don't really need the filtering, wrapping, mapping of HTTP request attributes to subject access review attributes. Like I don't really think they need that.
Oh, no, I didn't mean that layer. I meant like the delegated authenticator gives you an authenticator, which you would then use against the token, and then the delegated authorizer gives you an authorizer.
I
I'd be
would
happy
probably just use
suggesting that.
client Go directly.
I'd be happy suggesting either to them. But if you actually look at the API, it's really well factored into, I know about these things. I know what a user is. I know what a group is. I know what verb resource I want to ask the API server about. Let me make that request. And whether you use the API server delegator or whether you use just client Go and roll your own, I think you'll be able to understand it. The delegated authn also does things like retries. So that authorizer in the API server has some benefit beyond just wiring in. It does retries, it has caching, wires up arguments in standard ways. I could see that being useful. Because as soon as you do a remote request, everyone says, well, okay, now I want it cacheable. Now I want it cacheable for a certain lifespan. And I would be consistent with those arguments, even if you did roll your own.
Prasad, Ivan, you guys, are you all familiar with these APIs? I am not familiar with the APIs, so I cannot ask intelligent questions at this point.
Yeah, I had few, please correct my understanding. So once we generate the audience token, what are the ways to inject it to or pass it to the backup client? We talked about injecting it, but can it be fetched by using API, an API?
That's more the
pass
domain
it
of the
through
gRPC.
Yeah.
Yeah. There's a field in the gRPC API called session token. I assume you would use that to plumb the token to the driver.
Not to the driver, but so the backup client has to pass the. Okay, you're saying directly at the sidecar, we fetch the token and validate that, or the backup client should have the token and it should pass it to the sidecar, right?
The backup client should have the token and it should include that gRPC request.
He's talking about this field, I guess, Prasad. The thing is, is there a clear serialization mechanism for this token so we can pass it through and deserialize it the other side?
It's just a JOT. It's an opaque token. You should be able to just set it directly. And it can be treated as opaque actually all the way through to the CSI driver. The CSI driver is going to take that token and put it into a token review request and pass it to the Kubernetes API server and say, please tell me if this is valid and who this represents.
Okay.
So nobody needs to introspect the token anywhere in your chain.
Okay.
And I don't know if it's relevant, but I know Secret CSI Store, which is a CSI driver, uses bound service account tokens in a special way for sort of passing through application identities. I don't know if you have that same use case. The diagram is complex enough that I can't actually follow what actors are doing what. But that might be useful to you guys too. I don't know if it's relevant.
I think at this point, like the token review and subject access review APIs would be most relevant. We did take a brief look at the secret CSI driver. But yeah, maybe not for alpha version. I guess Carl, to your earlier question, no, I think this is I think this token review stuff, it did come up during our previous discussion. I think there was also a prototype being done on it, so we can always pull that back up to see where we left off. The reason why we started to roll our own like session token thing, I think, is because someone brought up that it has to be Kubernetes or platform agnostic. If we can, again, just be firm with the contract that says the sidecar is the place where all the Kubernetes call happens.
Yeah.
I think we can simplify that quite a lot.
Yeah, the CSI bits are agnostic, but the implementations on either end are Kubernetes specific. No matter which way you go, whether you're using service account tokens or using like Kubernetes object names, it's still Kubernetes specific, but that's fine. The CSI bits are agnostic.
Yes.
Right.
And I think you already said that the sidecar like uses UDS to talk to the actual backup thing, right? So like there's no
Yes.
concern about authenticating the sidecar to the backup thing. It is effectively part of the backup thing,
It is.
backup application over a well-defined interface that abstracts Kubernetes from it.
Yes, it is.
So I mean that seems totally fine. I think you're basically just gonna end up building a very Kubernetes specific shim.
Yes.
I think that's totally valid and expected.
Ivan Prasad, if I understood this correctly, then essentially we will fold the sidecar will fall in all the manager part of
Yeah.
the organization, right?
Yeah.
Because
Yeah,
if we
we
get
are
the
already doing. Yeah, I think we are already doing similar thing in manager.
Mhm.
We are using token review and subject access review for
Yeah.
authentication and validation. Just to confirm, so the backup client would use the token from service account, right?
I don't know which actors which. So like I would expect the shim between the backup thing and the rest of the world to use its own Kubernetes service account to do token review and subject access review on the incoming service account token, which belongs to whoever, whichever
Yeah.
asking.
The sidecar
Right.
will run with this lowest one, CSI driver service account, and the backup application will run with that service account.
Yeah, I think
Yeah.
so.
Yeah,
Now-
as Avan said, I think we had sometimes back we had discussed about this. Yeah, we'll have to, I guess, fall back to that.
Yeah, I think at that point, we did not understand how we could extract the service account. I think Prasad, I think we did not know about this API, right? Token request. Getting us, where's this? Where's the API actually?
So this one is different. This is the CSI driver one.
Yeah.
So I think you had your second tab or something was the one that
Token review.
I think this is the one
Yeah.
that
These are the
yeah,
data
so-
structures. Which is the API itself actually? So
I linked to the client Go. I'm assuming you're going to be using client Go or something built on top of client Go. But
yeah,
I
we
linked
use Anchor right now. Yeah.
I linked to the point in the client Go client set where you would make this create call.
So I mean, but based on what they described, it didn't sound like they needed dynamic audiences per app. So wouldn't it just be easier to ask the kubelet to do all the work?
This is token review. So
not token review. I meant for the provisioning of the actual service account token.
yes, to get the token, I also linked to the docs that show what it looks like inside a pod spec. I put that in the notes. Right.
Yeah.
There, if you want to pull it up. That's an example of asking for a token for the vault audience and then putting it at a specific point in the pod. So you could ask for a token for, the vSphere CSI driver or the whatever the audience that you come up with for the particular CSI driver. And if you do it this way, you don't have to worry about setting up any other permissions for making the token API requests to get the token, and the kubelet handles rotation of it for you. So it's a time limited token, but the kubelet will say at 80% of its lifetime, it'll fetch a new token and update it inside the pod. So inside the backup service pod, when you're about to make a backup request, you can grab the value from the token and make your request and be confident that it's always up to date.
I mean, yeah, typically the backup application pods are kind of ephemeral. They're launched.
It's like a
when-
job, like it starts, it runs, it finishes.
Yeah, and finishes. Yeah. So if this mechanism generates a new token each time, we wouldn't even know, I guess. So
So if it's long lived, then this is really nice because the kubelet will rotate it for you. If it's only going to read it at startup, then that doesn't matter as much, but it also is nice because the kubelet will get it for you. You don't have to write the client to request the token and make sure it has permissions and stuff. It just gets handed the token. So
Prasad, makes sense.
Yeah.
So the key here is the use of the audience. So if you don't include an audience there, then what you're actually getting is a token that is usable against the Kubernetes API server. And so if you hand that token to the CSI driver, what you've effectively done is given the CSI driver a token that it can use to do anything you can do against the API. So it's really important to include the audience here. So you can say, here's a token that identifies me, but only for this particular audience. You can't use it to like make Kubernetes API calls.
Yeah, so just to reiterate, so essentially, once we get that token in the where is this dude?
In the backup application.
Yeah, so the token from the backup application, we send it to the sidecar.
Mhm.
Then the sidecar can do subject access review on that token to make sure that the caller has access to the right things, correct?
First, the token review, get the identity, then take that identity and make subject access reviews to check whatever authorization you want to check. Yep.
Okay, that's what we wanted, and we couldn't figure out how to do it. Okay, we will again. I admit to being totally clueless on the API, so I'm going to have to read them up. Prasad, you're more familiar with them, but we may have to come back and ask you guys questions.
Yeah, no problem. To do it async, Slack is great. People are happy to answer questions in there. You don't have to wait for a meeting like this, but yeah, I think this will work well for you.
How is the just curious, how does the audience or the scope is being enforced, right? Is it like how do
When
do
you
it
do
as-
a token review, within that you tell the API server that I want this token to match the vault audience. And so the API server will say, cool, I'm going to validate all the crypto and everything, but at the end of it, I'm going to validate also that it's not necessarily valid for me, it's valid for some opaque string called vault, which is the audience. So if you don't specify that string, what you're asking the API server is like, hey, is this valid against you? Which is not the question you want to ask it. You want to ask it, is it valid against me, the backup service thing?
Right. So in this case, both the client and the CSI driver side, they have to agree on what that audience or that scope is.
Yep. So there are a couple ways to normally do it. One is like a well-known string. Like when I'm talking to Vault, I say Vault. Or when I'm talking to a vSphere CSI driver, I'm using the name vSphere CSI or whatever. That's one way to do it. Another way is to use the address or the name of the service you're actually calling to as the audience. So presumably the backup client knows something about the coordinates for the backup service that it's going to make a call to. And so you could use that name as the audience. So if it's going to be talking to foo.bar.baz to make the backup request, then it could ask for a token for foo.bar.baz. And
so is it like the DNS name of the service or something?
DNS name, yeah, exactly.
Got it. Gotcha.
I've seen both of those. They can both work.
Cool.
Or even the driver name. Yes.
Well, it could be the provision name or the service name. I mean,
Yeah.
The service name has the nice property that like as soon as you hard code something, it can accidentally get left. If you use the service name, then it has the nice property that if you talk to a different service, you're going to be asking for a different token automatically.
yeah, which is probably good. Yeah.
Yeah. Where
So
there's
this link with
multiple
somebody
CSI
with
drivers.
this link, who posted this? Anish, I'm not sure. So this is what is this about? This is
This is a different token request. This is within the CSI driver. This is between the
Yes, I don't know if
token
you need this
kubelet.
here. This is about how
kubelet talk
for a
to-
CSI driver to get the identity information about a pod that's going through the CSI interface, which is relevant in the case of something like Secret CSI Store, because it uses that token to then talk to like Azure Key Vault or Cloud KMS on Google or
I see.
AWS.
Okay.
So it's yeah, that's in the use case where you need the CSI driver to talk to some external identity, some external system, but it can't use its own identity, because using its own identity would require it to have all the privileges in the world. Instead, it needs to use an app local identity, so that way applications can have access to like individual secrets, and the CSI driver itself is permissionless.
Okay.
Mm.
Okay. So it's kind of like outward facing to a CSI driver into the infrastructure type of thing.
Correct. Yeah. So the token request API for service accounts was meant to be like a sort of like a platform agnostic way of validating Kubernetes identity to the outside world.
Mhm.
Obviously, it's used internally too, but that's what allows it to work, because the payload and schema are well defined, and providers support validating those tokens.
So can you go one more time over what permission? So the CSI driver service account, right, which is basically the one which is going to handle the delegated SAR, right? So does this need any additional permissions to use that token to look up stuff, or is it just implicit?
It's not going to be using the, are you talking about for the backup stuff we've been talking about the whole time, or this new
No,
thing?
it's for this specific problem we are facing here. So we're going to get the token, the audience token here, right? The audience scope token from the backup app coming here.
Yep.
This guy is going to use the SAR. What after does a token review, you said? Was that a token review API to validate that token?
Yep.
And then it's going to do an SAR with that token, correct?
Yep.
So is there
Or
any
with that identity.
right?
So
So any additional
It only
permissions?
needs those two pieces of information for validating the token. If it needs to access other Kubernetes objects
Mhm.
in order to do its job, then it would need permissions to read those things. We didn't really talk about what other information was in these that it would need to slurp up to pass to the CSI driver.
I think to your question though, you do need to grant that that sidecar or service account the ability to make token review and subject access review, because
Okay,
by
so this-
default you can't do that. That's
Okay, so
that's
I
the
see.
privilege
But
access.
so this one needs a permission to make subject access review checks
And token review.
and
Those
token review checks. Prasad got that?
Yeah.
Okay. Yeah,
Okay,
Prasad is the guy who understands this, not me. So sorry about the dumb questions.
Thanks, Carl. Yeah, I want to be sorry, we are 3 minutes past. Just want to be aware of everyone's time. I think this is very valuable and helpful. Thank you everyone for taking the time to talk us through this. If we have any questions, we'll reach out on Slack. Thank you very much.
Thanks, guys.
think so.
Bye.
Thanks, folks.